Is this what you think of when you hear someone say the word scientist? Lab coats, test tubes, and some weird experiment gone wild? These are the things Hollywood would have us believe. For many people, this is the image they have of a scientist. Of course, it is far from the truth. Actually, most scientists today work in teams because everyone knows teamwork often accomplishes more than individuals working alone. When people work together on a project, there is a better chance for the brainstorming of ideas and creative thought. Often one person's idea will help other people to generate new ideas or solutions. Here at Fermilab in Batavia, Illinois, teams of scientists are working together to explore the basic building blocks of all matter. The key here is teamwork and cooperation. Scientists are really just normal people who have a keen interest in their world and the workings of Mother Nature. Through their desire to learn about nature, there have been an unbelievable number of inventions and discoveries made, from electric pop-up toasters to space vehicles that carry people and satellites into orbit. Science is about finding out about things. It's a search for answers. Scientists are always asking questions and then trying to explain things through experiments and observations. A scientist is like a detective gathering clues, investigating leads, and evaluating observations. In the old days, thousands of years ago, the search for knowledge used to be called philosophy. The word philosophy comes from the Greek language. The word philos means loved, and sophia means wisdom. So philosophy is the love of wisdom. Philosophers were considered to be the wisest of people, and their teachings and ideas were respected without question. One of the most famous philosophers was Aristotle, who lived over 2,000 years ago. He was so respected that people believed anything he said. The problem was he wasn't a scientist. He never tested any of his ideas. Aristotle once proclaimed that heavy objects fall faster than light ones. Because he had such a reputation as a great thinker, people believed what he said for 2,000 years after he died. In fact, it wasn't until the scientist Galileo Galilei, living in the 1600s, conducted experiments to see if heavy objects fall faster than light ones. He rolled different marbles down a ramp and timed how long they took. He found that weight didn't affect how fast they fell. One story says that Galileo conducted an experiment at the top of the Leaning Tower of Pisa. The story says that he dropped 2 different-sized cannonballs. This really isn't the Leaning Tower, and this is an actor, not Galileo. The actor will drop a softball and a shot put instead of cannonballs. Well, here it goes. And the two land together, even though the shot put is many times heavier than the softball. Aristotle was wrong, but people believed what he had said for so long because it seemed to make sense. Aristotle probably observed something like an acorn fall and hit the ground, and then he probably compared that to something lighter, such as a leaf. Observing the falling of these two things led him to believe heavy objects fall faster than lighter ones. He never tested his ideas. A scientist doesn't make statements of fact unless he or she has backed it up with experiments and tests. That's what separates philosophers from scientists. What Aristotle forgot to take into consideration was the effect air pressure has on falling objects. For instance, these 2 pieces of paper weigh exactly the same. One is crumpled up, and then the 2 are dropped together. The crumpled one lands first because air gets in the way of the uncrumpled paper. In this case, the book is hundreds of times heavier than the single sheet of paper. If we drop them together, the book lands first. However, if we put the paper on top of the book so that air doesn't get in the way, the two land together, In the vacuum of space, where there are no gases to get in the way, all things fall at the same rate. In fact, these Apollo astronauts conducted an experiment to prove that Galileo was correct. A hammer and a feather were dropped together on the surface of the moon. As you can see, they land together. The word science comes from an old Latin word, scientia, which means knowledge. Science is becoming so specialized that it is being divided into smaller and smaller areas or fields of study. There are physicists, botanists, chemists, and biologists, and many more. The suffix "ist" means one who specializes in something. Galileo and the Englishman Francis Bacon are considered the founders of a method of investigation that is now referred to as the scientific method. This method was introduced in the 1500s. It is organized into logical steps. The first step was to recognize a problem. This meant observing nature and the world around us and recognizing a problem. Next, a hypothesis, which is an educated guess, is established. This is a way of explaining the problem or situation. Then, a prediction, or series of predictions, is made to explain the consequences of the hypothesis. Next, experiments are performed to test the predictions and the hypothesis. Finally, the results of experimentation are evaluated and a conclusion concerning the original hypothesis is established. Scientists are wrong more often than right, but they use this newly gained knowledge to help establish a new hypothesis. Scientists must know how to deal with failure. When data and results of experiments don't turn out as expected, they must rethink the problem and establish new ideas and experiments. If a hypothesis stands up to many experiments, then it can become a theory. If a theory seems to be correct in all cases, it will become a scientific law. However, theories and laws can change. They are being tested all the time. If a new observation shows a theory or law to be incorrect, then it is changed or even dropped. This method has been used throughout the world for the past few hundred years with great success. Yet, as good as the method is, it does not account for all scientific discovery. There have been many cases of discovery by trial and error. An example is that Thomas Edison tested hundreds of metals for the filament of the light bulb before he found the right combination of a tungsten wire in an airless environment. Sometimes scientific discoveries are made by accident. Becquerel found out about radiation when he placed a radioactive sample of uranium in a drawer with unexposed film. Later, when he went to the drawer, he found that something had exposed the film and a connection was made to the uranium sample. Success in science has to do with a common attitude among scientists to strive for answers through experimentation. Scientists have a natural curiosity about nature and how it works. As you can see, observation is a very important part of the scientific method. Observation is needed to discover a problem. Then, during the process of experimentation, observations are critical to collecting data and results. It is important for scientists to be careful observers because it is possible for our senses to be fooled. Read the message to yourself. Did you read, "She saw the birds sitting on the birdhouse"? Well, look again because it really says, "She saw the birds sitting on the birdhouse." Our sense of sight can be fooled if we aren't careful. Over the years, scientists have tried to develop equipment that can help with observations. One important discovery was made by an amateur scientist named Anton van Leeuwenhoek, who was interested in finding out about pepper. He thought that pepper must have a very gritty, sharp surface because it can make us sneeze. He made magnifying lenses and a simple microscope that were the most powerful of his day. He made an instrument to help the sense of sight. This led to better and better magnifying instruments that can open up the invisible world of the extremely small to our vision. He found that pepper was really round and smooth, which disproved his hypothesis, but it led to so much more. It wasn't long before he started looking at pond water and found one-celled animals swimming about. One experiment can lead to other ideas and further experimentation. Here is an ongoing experimental site in the Great Smoky Mountains. The scientists here are interested in finding out more about the effects of ozone on plant life. They have set up these domes to house different test situations. Each dome has the same number and variety of plants to be studied. All plants receive the same amount of water and sunlight. The water and sunlight are called variables. Anything that may change or vary in appearance or form is called a variable. When conducting an experiment, it is important that the variables are controlled so that only one variable is tested. In the case of this ozone experiment, the variable is the amount of ozone gas introduced into each of the different domes. Each dome receives a different amount of ozone gas. One dome receives no ozone gas. That dome is the control for the experiment. The control in an experiment is the standard for comparison. Results from the other domes will be compared with the control. Every day the plants are measured for growth. The number of leaves are counted, and the height of each plant is recorded. These scientists even have a special sensor that can determine the amount of photosynthesis that takes place. The sensor compares the exchange of carbon dioxide and oxygen from selected leaves and then can determine the amount of food making carried on by the plant. When experimenting, scientists must be sure that they are only testing one variable. They must have more than one test subject, and obviously careful observations and recorded data is crucial to understanding the outcome. So, in review, the scientific method developed by Galileo and Bacon back in the 1500s has helped scientists worldwide organize their approach to learning about our world. The method itself is organized in a series of steps, starting with recognizing a problem. Then, additional observations are made to learn as much as possible about the problem. Then, a hypothesis or educated guess is made to try to answer the question or problem at hand. Then, an experiment is developed to test the hypothesis. During the experiment part of the process, care must be taken to only test one variable. A control is needed for comparison. Data and test results must be carefully observed and recorded. Once the experiment is completed, the results are analyzed and interpreted. If the hypothesis is disproved, then it is rejected, and a new hypothesis may be written. If the hypothesis holds up to the experiment, then further testing may be carried out. If it continues to hold up under many experiments, it may become a theory. And if the theory seems correct in all cases, then it may become a scientific law. Scientists must be able to deal with disappointment and failure. They should understand that each failure adds to knowledge and can lead closer to the final solution to problems. Scientists have inquiring minds that want to discover answers to the challenging questions of our natural world. Technology is the use of science in a practical way. Signs of technological advancement are all around us. Science and technology are not the same, but they are connected. Scientific knowledge is used to develop new inventions, and new inventions help to make further scientific discovery. And it's the desire of scientists to find out about the unknown that keeps the whole sequence going. Back in the early 1900s, the United States Patent Officer in charge of patenting inventions suggested that the office be closed. He reasoned that everything useful to man had now been invented, and therefore the office was no longer needed. He made a slight error, especially when we consider everything that has happened since the early 1900s. There will never be an end to the human desire to create, invent, and explore. Humans are interested in knowledge. Discoveries of one kind lead to fresh questions and problems. It is a cycle that will never stop.